the general form of a log equation, a log graph. And if you look on page 266, example 5, it's the same process. So what am I noticing? I'm noticing that the vertical asymptote in this graph is at x equals 2 instead of at 0. So I know it's been shifted right too. So I'm going to write a times the log of x minus 2 plus some k, some vertical stretch. I don't know what that is. I also see that instead of the log function going up like this, it's been reflected around the x-axis, so I know my a is going to be negative. I'll leave it positive for now, but I know I'm going to have a negative answer there. So what else do I know? Well, I see it's also going through the point 3, 1. So maybe that can do something for me as far as finding k to find some vertical shift. So I know 1 has to equal a times the log of, well, let's see, 3 minus 2 is 1, plus some k term. Well, the log of 1 is 0, because to 10 to the 0 is 1, which cancels out that whole mix. So it's been shifted up 1, I can tell. So I know f of x equals a times the log of x minus 2 plus 1. Then I see it's gone through this point 4, 0. So 0 equals a times the log of 2, right? Because 4 minus 2 is 2, plus 1. So I guess I can solve for a. I'm going to subtract 1 and then divide by the log of 2. So that equals, that's what a should be. So I'm thinking f of x equals negative 1 over log 2 times the log of x minus 2 plus 1. Now we've got one other point. I mean, besides graphing it, I do have one other point I can use. I can use that 6, negative 1 to see if that's what I've got. So negative 1 equals negative 1 over the log of 2 times the log of, well, 6 minus 2 is 4, plus 1. So then what I can do is think of it this way. I know the log of 2 is the same as the log of 2 squared. Log of 4 is the same as log of 2 squared. I can bring that 2 in front. So negative 1 equals negative 1 over the log of 2 times 2 times the log of 2 plus 1. Well, that log 2 and that log 2 cancel out. So that leaves me 2 times negative 1 is negative 2, plus 1 is negative 1. So that's the equation of this graph. Where is it? Right there. So we can drag this around. Okay.